Hello everyone, my name is Prasanna Kumar Reddy. I am presently pursuing my course semester in Teshwara College of Engineering, and the course name is Database Management System, and the course code is BCS 403. Now we are going to learn about the topic of ER diagram of student registration system. As you can see, like in a student registration system, it visually represents the entities, attributes, and the relationships involved in the system. That like these are the things which are display like we can see in the ER diagram, and it helps in understanding the data flow and organization within the registration system. Like whenever you start an organization, it helps to understand like the using the ER diagram, we can understand the data flow and how it works and everything, all the stuff. And the ER diagram serves as a blueprint for designing and implementing the database. As I said, it helps to understand how it works, everything. So it serves as the blueprint and designing and implementing the database structure. And in entities, like these are the things which are involved, like the entities, relationship, attributes, other stuff which are involved in the ER diagram. And in entities, it mainly involves like in the student course code, instructor registration, all these stuffs are included in the entities, like which places the topic name. And each entity has its own set of attributes that describe the characteristics of the entity. Like you can say in simple words, entity is the title name and it has the set of attributes which describes the entity. And for example, student entity may have attributes such as student ID, name, and email. And in relationships, in the ER diagram, define how entities are connected to each other. A student can register to multiple courses, creating many-to-many relationship between them and as the student and course entities. For example, like one student can study many subjects you can take when it comes to the course. You can take like physics, chemistry, mathematics, Kannada, English, any subject like one to many. And an instructor entity can teach multiple courses, establishing one-to-many relationship between the instructor and the course entities. As you can see, like the product, as it can just a minute. As you can see, the product is the entity, and the price, name, category are the attributes which has a relationship in this. And for example, if on the product to company, like product is the manufacturing that makes is the relationship between the company and the product. And for the company and the person, it is the employee relationship. And company is the entity, the name and the stock price are attributes. And for person is the entity, for person, address, name, and SSN is the attributes. And person and product relationship is like purchasing the products. And cardinality in the ER diagram specifies the number of instances of one entity that can be associated with number of instances of another entity. For example, a student can register for many courses. As I said in the previous example, like one student can study many subjects like mathematics, chemistry, then environmental science, computer science, or ADA, DSA, anything like it. A student can study many courses from like one to many. Cardinality constraints helps in determining the types of relationships between entities. Attributes. Attributes in the ER diagram represent the properties or characteristics of the entities, as I said in the previous diagram. As you can see in this image, ticket, the attributes are ticket amount, ticket date, ticket ID, and ticket number. For passenger, it is passenger name, passenger ID, passenger number, and passenger age. Like these are all the steps which are circled in a oval shape or called as entities. And the box shape, those are the entities. And in the diamond shape, those are the relationships. And each entity has a set of attributes that describe the entity's data. Like these are the data of this entity. For example, the course entity may have attributes like course code, title, and credits. And primary key. A primary key is a unique identifier for each record in a database table. It is used as an identifier in the database table. In student registration system, the student entity may have student ID as a primary key. The primary key ensures the uniqueness of each record as it helps in identifying records in the database. As in student registration database table, student ID is mainly used for like in a serial form of student numbers where we can store data in a particular ID, and it helps, and primary key plays a major role because it acts as an identifier and it helps in identifying records in the database. And foreign key. A foreign key is a field in a database table that links to the primary key of another table. In student registration system, the registration system may have foreign key that links to the student and course entities. Foreign keys establish relationship between entities and ensure data integrity. As you can see in this, field 1, field 2, field 3, field 4, and field 5, field 6, field 7. Like field 2 and field 5 are connected, and the field 4 and field 6 are connected, which acts as a primary key and foreign key, and these are the foreign key fields. And normalization. Normalization is nothing but creating is to reduce redundancy and dependency. Like you can see in this table, there are like outlet ID, outlet location, contact number, and outlet ID is only one. But in a location, it has like street, city, and pin code, and contact number, they have two contacts. So basically, it's in a complex form, and reducing them to the normalized, like a simpler form, like outlet ID, outlet street, outlet city, pin code, contact one, and contact two. Like the upper one is like in a complex form and the below one is in like a simple form. So it helps in reduce redundancy and dependency without depending, like in this form, in this database, we can't depend on which city it is or which city it is. So if we do the normalization process, we can easily identify which is what. It involves in breaking down large table into smaller tables and defining relationships between them. It's a set. It helps in breaking down from the complex form to the simple form. And normalization helps in maintaining data consistency and improving database performance. Here diagram example. A sample year diagram for student registration system may include entities like student, course, instructor registration, relationships such as student registration for courses and instructor teaching courses are depicted in the diagram. As you can see in this diagram, all are interlinked. If the student is connected to the enrollment, and these two are connected to the lecture, and lecture is connected to the lecture and subjects. Attributes like student ID, course code, and instructor ID are included to describe the entities. As you can see, student, enrollment, lecture, and subjects are the entities, and the attributes you can see are the first name, last name, NID, address, date of birth, and the student number, date of enrollment, course name, first name of lecture ID, and the last name of lecture, and email address, subject course, subject unit. These are all comes under the attributes. And in conclusion, overall, we can say that a diagram of student registration system plays a crucial role in database design and development. It provides a clear visualization of entities, relationships, attributes, and constraints within the system. Understanding the ER diagram helps in creating an efficient and well-structured database for student registration. Like a database of student consists of like many entities, attributes, relationship, and the constraints within. From the ER diagram, we can understand all these concepts. And overall, we can say that the ER diagram plays an important role in the